Let's do some probability. Okay, when tossing a two-sided fair coin with one side colored yellow and the other side colored green, determine the probability of yellow. For all of these probability questions, we're going to have the same setup. It's going to be a fraction. On the top of the fraction, we're going to have what we call the favorable outcomes, what we're trying to get or trying to find. And on the bottom, we're going to have the total outcomes, right? So in this situation, the favorable outcome is that the coin lands on yellow, right? There is one side that is yellow out of a total of two sides of the coin, right? So there is one way that this could turn out to be yellow out of two possible outcomes. So the probability is 1/2. Now that 1/2 could be written as a decimal or a fraction or a percent, right? So just as a refresher, remember, fraction bar means divide. Remember what I learned from TikTok, that the division symbol, right, is really just a fraction with dots holding the place of the numerator and denominator. So when you see a fraction, I want you to think divide. If you divide 1 by 2, you'll get 0.5. 0.5 is 5/10 or 50/100, or you can move the decimal 2 places to the right to convert that decimal to a percent, right? Another way you could do it is you could say, well, I know that 1/2 is 5/10, and I know that that's 50/100. And anytime you have anything over 100, that means the same as percent, right? Because hundredths and percent mean the same thing. All right, so this answer could be in any of the forms. It's 1/2, but it could also be 0.5. It could also be 50%. When rolling a fair 8-sided number cube, determine the probability of getting a number greater than 2. Well, let's look at all the possible outcomes, right? Let's just write them all out. So 8 sides means I would have 1, 2, 3, 4, 5, 6, 7, 8. And so my total, remember it's favorable over total. So my total number of outcomes are 8, right? Because there are 8 different sides that could land facing up. And the number of values that are greater than 2 are these, right? How many are there? Count them. Really, count them. Right now, count them. 1, 2, 3, 4, 5, 6. There's 6 of them. So 6/8 is the answer here, but that could be reduced, right? Because those are both even. If I divide both of those by 2, think about what I'll get. You thinking? Did you come up with it? 3 on top, and then 8 divided by 2, 4 on the bottom. Now, 3/4 is one of those common fractions that you should commit to memory. If you don't remember the decimal for 3/4, there's lots of ways to get it, but the decimal for 3/4 is 0.75 or 75/100. And we know that if it's 75/100, that means the same thing as 75%. All right, so any form is acceptable. It just depends on if it's multiple choice, what the options are. Spin a spinner with 3 equal sections colored red, white, and blue. What's the probability of getting green? Well, there are 3 total outcomes and none of them are green. So the probability of getting green is 0. There is 0% chance you're going to get green because you can't get green. It's not an option, right? If something is totally certain, we say that has a probability of 1 or 100%. If something is impossible or will not happen, we give that a probability of 0. or 0%. All right. When given a set of cards laying face down that spell math is fun, determine the probability of randomly drawing a consonant. Okay, so again, we've got favorable over total, right? Our favorable is going to be the number of consonants. Consonants. Make sure I spell that right. And then the total will be the number of, like the total number of letters, right? Number of letters total. Okay. So let's look at the total first. How many letters do I have? 1, 2, 3, 4. You're counting with me, right? I'll start over. You can count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 letters total. Now, let's circle the consonants. The consonants, not A, right? T, H, not I, skipping over I, S, F, skipping over this letter right here, and then N. So, how many letters did I circle? I'll pause so that you can count. 6 of them. So my answer is 6/9. Now, again, lots of ways we can write this, right? First of all, I can reduce 6/9 because those are both divisible by 3. Divide 6 by 3, and you get 2. Divide 9 by 3, and you get 3. So 2/3 is the same as 6/9. I could also do that on the calculator. 2 divided by 3, it gives me a repeating decimal, right? So you probably won't see this one in decimal or percent form. You could. More likely you'll see it in fraction because, since you have to round, it's not exact. But if I had to round, I could round this to the hundredths place, right? Since it's a bunch of repeating 6s. If I wanted to round to this decimal place right here, to round it to the hundredths place, I'm going to use little squiggly lines to show that I rounded. Then I would look at the next number. It's 5 or above, which means this 6, I got to give it a shove. So it would become 0.67 or approximately 67%. Right? Okay. A spinner with repeated colors numbered from 1 to 8. Repeated color. Oh, some of the colors are repeated. Okay. Is shown. Sections 1 and 8 are purple. Sections 2 and 3 are yellow. Sections 4, 5, and 6 are blue. And section 7 is orange. Determine the probability of not blue if the spinner is spun once. Okay, so again, favorable over total, right? In this case, my favorable are the ones that are not blue over my total outcomes, right? So I have 8 different spaces that the spinner could land on. So my total is 8. How many are not blue? I'm going to give you a minute to count them. Or you could do the total minus the ones that are blue, right? That would also work. So the ones that are not blue are 1, 2, 3, 4, 5. And then 5/8 on the calculator. Ooh, you know what? I didn't do this one. I think 5/8 is 0.625. Let me just verify that. Is that right? Or no, times 5. Yeah, yeah. So if you do it on the calculator, 5 divided by 8, you'll get 0.625. And when you convert that to a percent, remember we moved the decimal 2 places to the right. Remember we had that little way of remembering it, like D comes before P in the alphabet. So we go 2 to the right to go decimal to percent, and then 2 to the left to go percent back to decimal. Just a little like way that you can remember which way to move the decimal point. Just remember which one comes first alphabetically. So if I move this decimal point 2 to the right, then I will get 62.5%. That is the probability that the spinner does not land on blue, or lands on not blue. Okay, Joseph has a bag filled with 2 red, 4 green, 10 yellow, and 9 purple marbles. Determine the probability of not green. Here we go again. Okay, so our favorable over our total is going to be not green over the total. Not green. Okay, so not green would be these 2, these 10, and these 9. When I add those together, 9 plus 2 is 11. 11 plus 10 is 21. And then my total, I would have to take that 21 plus add the 4 green that I left out, and that would be 25. Now, you could do this on your calculator. I don't know what I was thinking. I didn't even bring a calculator when I came over here to sit to do this video. So I'm going to do it a different way. But if you have a calculator, you could do 21 divided by 25. I don't have one right now. So the way that I'm going to do it is I'm going to do 21 over 25, and I'm going to convert this to something over 100. I know that 25 times 4 is 100, so I just have to do 21 times 4. So 20 times 4 is 80. 1 times 4 is 4, so I get 84. So that would be, as a decimal, 0.84, right? Because it's 84 hundredths. As a percent, 84%. Now, if the probability that it's not green is 84%, think about this, you guys. What would be the probability that it is green? I know it didn't ask you that. I just want you to think about it. If the probability that it's not green is 84, how could you find the probability that it is green using that 84%? Well, it's either going to be green or not green, right? Those are the two options. It's either going to be green or it's not going to be green. So if the probability that it's not green is 84%, then 100 minus 84, which is 16%, would be the probability that it is green, right? This would be not green, which is what they asked for in this question. This would be the probability of green, which is just a little extension question that I wanted to ask you myself. Okay. A group of students was surveyed in a middle school class. They were asked how many hours they work on math homework each week, and the results from the survey were recorded. Determine the probability that a student studied for 4 hours. Okay, so still we need favorable over total, right? So our favorable here is going to be the number of students who studied for 4 hours. Our total is going to be the total number of students. So let's look at that. To get the total of number of students, I'm going to have to add all of these up. Man, I really should have brought a calculator with me, but I am going to use my number sense instead. So I know that 7 and 3 makes 10. I'm going to write that, I guess I need a different color. It's fine. So 7 and 3 makes 10. And then 9 and 1 makes another 10. And then these added together, 5 plus 2 is 7 plus 3 is another 10. Okay, perfect. I can do that. That's 30. And then the number of students who studied for 4 hours. So I'm going to come over here in my hours column. I'm going to look down till I get to 4, and that was 9 students. So 9 students out of 30 studied for 4 hours. We could reduce this. We could divide the top and bottom by 3. 9 divided by 3 is 3, and 30 divided by 3 is 10, right? And then from there, we could convert to decimal or percent, right? If I want to make a decimal, well, that's easy, 3/10. It's literally a decimal place, right? The tenths place. So 3/10 would have a 3 in the tenths place. Or you could look at this, 3/10 is the same as 30 hundredths, right? Which is 30%. Or you could take this decimal point right here and move it 2 places to the right and also get 30%. So that would be our answer. It would be 3/10, 0.3, 30%. Any of those. They're all correct. All right, have fun working with some probability questions and let me know if there's anything that I can help with.